Okay, in 5.4c, we're going to do transforming the cosine graph, okay? If you recall, when we did the parent function of cosine, it looks like this, okay? Looks like this. It ends at 2 pi. It starts up at 1, and it comes down to -1. So it's very cyclical, just like the sine curve is. And I've gone ahead, just for time's sake, and put in the parent points, or the key points for each of these, just to save us some time in the video. But we're going to apply the same formula that we did in the previous video, where it's 1 over b times x plus c, and then it's a times y plus d. That will give us our transformed points. So we have to be aware of where are those points in the equation. So very, very similar to sine, our graphs are just going to end up looking different. So let's just start with number 1. So if I look at my equation, I'm going to notice that a is 3 and b is 1. So this should be a pretty simple one to transform. So it's 1 over 1x plus 0, right, because c is 0, and then 3 times y plus 0. So what really is going to happen, x stays the same, and we're just multiplying y by 3. That's all we're going to do. So let's apply our points. Let's get our new points. X is going to stay the same, so 0, 1 times 3 is 3. Pi over 2, 3 times 0 is 0. Pi, -3, 3 pi over 2 stays the same, 0 times 3 is 0. 2 pi, 1 times 3 is 3. All right, here's my new points. So I'm going to go back in my graph and look at my x values. They stayed the same, right? So I label them. And my y values, however, have changed, right? So I need to go 1, 2, 3, label 1, 2, 3, label. So 0 is going to start up here, 0, 3. At pi over 2, I'm still at 0. Pi, I'm down at -3. 3 pi over 2 is 0, and 2 pi is back up at 3. So smooth, continuous curve with rounded edges and arrows. So there's my new transformed sine curve. Same properties as before. A is the amplitude. The absolute value of A would be 3. B was where does the period begin and end? So it begins in this case at 0, and it ends at 2 pi. Since B is 1, 2 pi divided by 1 is still 2 pi. D is the x-intercepts. Where does it touch the x-axis? Okay, it touches at pi over 2, 0, and at 3 pi over 2, 0. E is the maximum. So notice that this one has, when you do cosine, you got 2 maximums, don't you? We one at 0, 3, and then at 2 pi, 3. One minimum at, where is that, pi, -3. Domain, like before, it's a continuous curve, so the domain is all real numbers. And the range from lowest to highest, -3 to +3. There it is. Let's try the next one. Okay, A is 1. B is 1/2. C is not there, D is not there. Okay, so what's going to happen? So when I do 1 over 1/2, isn't that, keep it, change it, flip it, doesn't that turn into 2x? And then y is just y. There's no C, there's no D. So really I'm just multiplying my x values by 2. Y values are staying the same. So let's do that. X values, so 0 times 2 is 0. Y stays the same. Pi over 2 times 2 is pi. Pi times 2 is 2 pi. 3 pi over 2 is 3 pi. Notice the pattern here. It's just going up by 1 pi, isn't it? So this would be 4 pi, 1. All right, let's plot our points. My x values are 0, pi, 2 pi, 3 pi, 4 pi. Y values haven't changed, so it's still 1 and -1. So 0, 1, pi, 0, 2 pi, -1, 3 pi, 0, and 4 pi, 1. All right, smooth continuous curve with arrows on the ends. There it is. And we can apply all of our properties. So amplitude, well, it's just 1. Absolute value of 1 is 1. B is, where does it begin and end? Well, it begins at 0, but it ends at 4 pi. So C is the period length, so 2 pi divided by 1/2 turns into what, 4 pi? D is the x-intercept, so I have an x-intercept at pi 0 and then at 3 pi 0. Maximums occur at 0, 1, and then all the way at 4 pi, 4 pi 1, sorry. Minimum is at 2 pi negative 1. G is domain, negative infinity to positive infinity. And then H is range, so negative 1 to 1. Okay, let's look at number 3. A is negative 2. B is 6. So it's very similar to what we just did. Pause the video, try it yourself. If you still need support, just keep listening. But you can try it and fast forward as you wish. Let's see what happens here. So if I know, let's see, B is 6, so it's going to be 1 over 6x, there's no c, and then negative 2y. Okay, so I'm going to take my x values and multiply by 1 over 6, so it's still 0. 1 times negative 2 is negative 2. Pi over 2, that becomes pi over 12. 0. Pi over 6, positive 2. So be careful, 3 pi over 2 times pi over 6 is 12, that cancels. So it's pi over 4, 0. And then 2 pi over 6 reduces to pi over, oh, not pi over 6, pi over 3, right? And then that would be back to negative 2. Okay. So it's reflecting, right? That negative 2 is reflecting it across the x-axis, but it's going to start at 0. My x values go in order from least to greatest if I've done the math correctly. Pi over 4, and then pi over 3. Okay, my first point is at negative 2, 0, positive 2, 0, negative 2. So you can see it's just a reflection of what we did. All right, properties. Amplitude is 2. Where does it start? It starts at 0, ends at pi over 3. So 2 pi over 6 reduces to pi over 3. That's the period length. X-intercepts are at pi over 12, 0, and at pi over 4, 0. Maximum, there's only one maximum here, and it's at pi over 6, 2. But now I have two minimums, don't I? This was at 0, negative 2, and at pi over 3, negative 2. Domain is all real numbers, and range negative 2 to positive 2. All right, hopefully you're getting the hang of this. It is tedious, but not impossible. Let's try the next page. All right, let's look at this. So A is 1, B is 1, yay. C, remember to change our sign for C, so it's a positive pi over 4. D is 0. So all I really have to do here is add a pi over 4 to each of my x values. That's what it's going to translate to. Don't let it get to you just because it's a fraction, but we can do this. So let's do this. So let's do pi over 4. So 0 plus pi over 4 is pi over 4. Y stays the same. Pi over 2 plus pi over 4. Okay, if I get a common denominator, that becomes 2/4. So this is 3/4, 0. Pi plus pi over 4. That's 4 over 4. So this would be 5 pi over 4. Y stays the same. 3 pi over 2 plus pi over 4. That's 4. And that'd be 6. So this would be 7 pi over 4. And 0. Notice what's happening to my x values. Look, I'm just going up by 2 pi over 4 each time, half, right? A pi over 4. So it's going 1, 3, 5, 7. Guess what the next one is? It's 9. 9 pi over 4, 1. There it is. Feel free to use those patterns to help you out. Now, as we plot our points, notice it's shifting off the y-axis. So it's pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, and 9 pi over 4. Y values are stayed the same. Amplitude didn't change, okay? So at pi over 4, I'm starting here. Then at 0, -1, 0, 9 pi over 4. So it's taken our curve and just shifted it to the right by pi over 4. Hopefully that makes sense when you look at the equation again. What happened? It just moved this way. Okay, amplitude is just a 1. Where does it begin? It begins at pi over 4, and it ends at 9 pi over 4. If you take the difference of that, you get 8 pi over 4, right? Which is really just 2 pi. That's the length of the period, which should make sense because 2 pi over 1 is 2 pi, right? D is the x-intercept, so I've got 3 pi over 4, 0, and then at 7 pi over 4, 0. E is the maximum, so I still have two maximums. I have one at pi over 4, 1, and then at 9 pi over 4, 1. F is the minimum. It occurs at 5 pi over 4, -1. Oops, there's just one minimum. Sorry about that. Domain. Remember, domain is all real numbers. There's no breakage in our curve. That's why we have the arrows on the ends. And then the range goes from -1 to +1. Okay, great. Now, number 5. 5's a doozy because we have all 4. A is going to be what? 2/3. B is, we'll come back to B. And we'll come back to C because I want to talk to you about this. Now, D is clearly a 2. Now, why did I stop here? Because I want you to remind ourselves the very first generic equation we had with this looked like this: cosine, and it had this weird bracket, x minus c plus d. All right, why did it do that? Because b is really outside the parentheses. But notice in our equation, there's no b on the outside, is there? So what does that mean? That means they distributed the b. So we have to factor it back out to find out what b really is, and it also will change what is c really going to be. So let's just think about this for a second. If I have x over 2 plus pi, that means I have 1/2 times x plus pi, right? If I need to factor that 1/2 out, I'm left with x. But what happens to the pi? So let's logically think through this. So we're doing pi divided by 1/2. So if I keep it, change it, flip it, that becomes a 2 pi, doesn't it? Now the way to check this is go back and distribute. If I distributed this back out, I would end up with 1/2 x plus pi, and that should be what I had in the original equation. Is that what I have in the original? It is. So I know I factored this correctly. Now why the heck did we have to do this? Because this is b, 1/2, and this is the c. Remember, I have to change the sign, so it's -2 pi. If I just look at it in the equation as it is, it's going to look like, okay, b might be 1/2, but c looks like it's just pi, but it's not. So you have to be really careful and observant when you look at these with a b and a c. All right? I'm not trying to confuse you. I just want you to be aware of these little idiosyncrasies that happen. So now that we know what a, b, c, and d is, let's apply it. Let's find our equation. What the heck is it we're going to really do to this? So let's see. It would be 1 over 1/2 x minus 2 pi, 2/3 y plus 2. All right, let's clean that up. 1 over 1/2 x, if I keep it, change it, flip it, that's really 2x minus 2 pi, and then 2/3 y plus 2. All right, I would encourage you just to take x's first and then do the y's, or vice versa, whatever you want to do. Don't get too overwhelmed with it, okay? Let's look at our x's first. So if I take x, 2 times 0 is 0, minus 2 pi would make it -2 pi. I'm going to space it, okay? Pi over 2 times 2x would be pi. Minus 2 pi makes it -pi. 2 times pi is 2 pi, minus 2 pi is 0. That was easy. Now, 2 times 3 pi over 2, what is that? That's 3 pi. Minus 2 pi leaves me pi. Do you see a pattern? We're going from negative pi, 2 pi, negative pi, 0, pi, and guess where this one's going to end up? Back at 2 pi, surprisingly. So 2 pi times 4, or 2 pi times 2 is 4 pi, minus 2 pi gives me back to 2 pi. Now let's address the y values, okay? Okay, 1 times 2/3 is 2/3. So 2/3 plus 2. But if I need a common denominator, that would be 6/3. So that would make that 8/3. 0 times 2/3 is 0 plus 2 is 2. -1 would make that -2/3. Plus 2 would make that what? 4/3. 0 plus times 2/3 is 0 plus 2 is 2. And we're back to 1, which we had up here. So we know that one becomes 8/3. Okay, so a little tedious, but we can do this. Now we are going to have to change up our x-axis, aren't we? I'm sorry, our y-axis, because we have to start way over here. So I'm going to relocate my y-axis and forget that that's there, okay? Okay, so let's look at this. Our x values start all over here at -2 pi, -pi, 0, pi, and +2 pi. So you may need to alter your graph just slightly. Look at our y values. They go from, so our y values, let's think for a moment. 8/3, remember, is 2 and 2/3. This is a 2. This is 1 and 1/3, a 2, and we're back over here at 2 and 2/3. Okay, so my y values really need to go from 1, 2 to 3, right? I don't really need anything below the y-axis, but that's okay for now. And let's plot our points and see where we end up, okay? So at -2 pi, I'm up at 2 and 2/3. -pi, I'm at 2. Here I'm at 1 and 1/3. Then I'm back up at 2. And then I'm back to 8 pi, or 8/3. So 2 and 2/3. So it is making that same shape, but notice it's like vertically shrinking it, isn't it? Vertically shrinking it. Hopefully that makes sense based on your knowledge. Okay, let's do our attributes. The amplitude is A, absolute value of A, so it's 2/3. B is, where does it start and stop? It starts at -2 pi, it ends at +2 pi. Well, the period then is 2 pi over 1/2, which translates to 4 pi. D is our x-intercepts, but notice it doesn't touch our x-axis at all, so we would say none. E is maximums. Okay, maximums occurred where it was 8/3. That happened where? At -2 pi, 8/3, and then at +2 pi at 8/3. Our minimum is at 4/3, so that was at 0, 4/3. Domain, it's a continuous curve, so it's -infinity to +infinity. And then lastly, range. Very small range, isn't it? +4/3 to 8/3. Very, very small. Okay, so hopefully you'll see similarities on how we transform these graphs. Cosine and sine are very, very similar. They have the same period length, different points to start with, but the process is the same. So hopefully you're getting this. Let me know what questions you have and how I can help you in class.